have now arrived at the most requested talk from our JUG attendees. So we have two architects from Sabre corporations with us here, Prashant Hegde and Bhuvana Venkatraman. With their over 20 plus years of experience with Java and microservices, they are here to demystify observability for us. So I'll just hand it over to you guys.
Thanks, Jayashree. That was a good start. So I think we have quite a lot of responsibility on us to keep everybody awake right after lunch. Right. So okay. As Jayashree mentioned, I'm Prashant Hegde. So I work as a senior principal architect in Sabre Corporation, and I've been working in Java for close to 2 decades now. And primarily, we deal with building large-scale microservices, designing, developing, architecting those in Sabre, and we basically kind of adopt a lot of these technologies within our day-to-day work. So, Bhuvana, you want to introduce?
Yeah. Hi everyone, I'm Bhuvana, and I started as a mainframes programmer, and over the years I've worked in different technologies, mostly in applications side of it, and recently moved to enterprise architecture. And with that, Prashant, do you want to continue?
Okay. I think before we get started, we just set up some kind of an agreement how we really want to showcase it. And I think we have we try to really shrink a lot of contents in a very small duration. So what we really try to do that is keep the questions slightly towards the end. So we just want to talk about some of the concepts, and then we really have a small demo to showcase what we're really talking to, again connect the dots, and then we'll basically open it up for the questions. So with that, I think without delay, let's get started. So yeah, you want to take it?
Okay. Yeah. So first of all, thanks for this opportunity, and we are glad that we are able to present on this topic. And we just want to start setting the context with observability. So if you see the first one, the quote is completely unrelated to observability. But then look at the words in bold. So known unknowns, we would like to attribute that to the metrics that we are going to talk about. The known unknowns is basically what observability is going to show you, as you drill through it. And unknown unknowns are always going to be there, and the whole software is about solving those unknown unknowns, right? Or maybe they are just there. So with that, we move on to the what is observability. Observability is basically just understanding the internals or the workings of the system through its visible outputs, right? And it's not a new topic, it's always been there. We've always had logs, and as a programmer, I'm sure you would have written the hello world, printing hello world to the console. So it's always there. You always keep looking at what the program is doing. But then let's see what's more to it, right, as you build more complex applications. And of course, with that, I think we'll just want to cover the agenda. We want to look at observability, what Spring Boot is offering, and some best practices, and then probably a small demo, and then we will move on to Q&A if we have time, or we can always catch up in later in the evening if you guys are interested to talk more on this topic. So with that, like Prashant said, we want to set the context that some of the examples that we show, some of the tools that we mention is basically as illustration. We are not saying that this is the only tools available to build your observability pipeline, or that's all there in the observability product. I mean, if you look at it as a product, in the product. So let's first look at this diagram. The diagram that you see is basically a real diagram. It's a dependency graph or a service graph, where it's taken from Uber's diagram some years ago, and it will have, I think, close to around 2000 plus microservices, and each node that you see is a microservice, and the edge is nothing but the communication that's happening between the microservice. So imagine the scale of this application, and imagine if you have to debug or analyze a problem in the service, where would you start, right? So that's what observability is going to basically attempt solving for you. And so that as you debug the application, there are questions that you might you might be asking yourself. So let's say you have an outage, so what is happening? What if some request is failing? So which request is failing? What is what is the error that you are observing, or is there even an error? And also, what is happening if you know a service which is actually causing the error, what is happening inside that application that's causing that error. So you should be able to answer all of these questions as you look through your logs. And basically what we are going to provide in this session is just a starting point, like how you can build your observability pipeline. So with that, I think we'll get into the crux of the topic and look at what are the pillars of observability. And some people don't like to call this as pillars, but then let's keep it that way so that it's people are familiar with this more. So first is logging. Logging has always been there in the industry, but what is different in logging in the new world is that as applications are getting re-architected and written as microservices, the inherent problem of observability gets complex. Like, let's say you have 100 services logging to some central system. You don't know how to correlate or track a transaction across the 100 services. You don't know which services they are hitting, right? So logging with context aware logging is going to help you debug the system more faster. And then metrics again is probably the cheapest way to log, because it's more accurate in terms of capturing numbers, right? And you have tracing, again tracing in the context of what is the transaction, what services the transaction is hitting, how long it's taking, how to look at latency, right, where the transaction is spending more time on, and all of those problems. And visualization, of course, to understand the whole gamut of the logs that you're collecting in a human understandable way. With that, I hand over it.
So with that, basically the context, I just want to take a moment just to revise back, I think, what Bona touched upon, right? Again, I think to start with, there is no one size fits all solution. So here the Spring Boot, being a bootstrap technology to really expedite the development and building of a microservices, do provide some of the vendor neutral libraries and frameworks that can just basically include it into that application. It auto configures and start really streaming the data to the any maybe a visualization or any a dashboard building tools like Grafana, or there are many in the industry which can really it can feed the data into. So again, I think if I just look at the way that the Spring Boot developers or a Spring Boot core community defines that observability API as, they just wanted to really build an auto configurable. So that is basically the code taken right from one of the Spring Boot developer, right? The idea of its founding was that we wanted users to instrument their code once and use a single API to have all the multiple benefits that what the observability aspects are really going to bring out. So that is exactly where they really ended up with a micrometer library that is kind of a very natural to Spring Boot, and then it goes really well with a Spring Boot framework. So we just have to really have drop in some of those libraries, and then it auto configures focusing on the important data, and it also very flexible and customizable as the needs. If I really want to expose some custom data according to my business application, the business data really want to be exposed, yes, it do provide that extensibility within that. So going forward now, we kind of like go a little bit deep into that each of the pillars that what we touched upon, that basically constitutes that umbrella of observability. So to do that, we really have like a sample use case is something that we're really going to refer back and forth again, and then the same thing is something that I'm going to show in the demo as well. So we kind of like took a very simple basic use case where we have like a 3 microservice. One is primarily, it's a very classic e-commerce use case where you shop and you do a cart management and then you do the purchase. So we basically have these 3 microservices defined, and then we picked, this is one of the standard open source tooling which will really help us build this observability infrastructure. That is something we picked, but we are not really like kind of like marketing for this. This is just like what we picked for the demo purpose. There are like n number of different tools and frameworks available to do the same thing. So here, if you see here, how we are really doing that instrumentation of our application. So here in this use case, these are the 3 microservices in my application. And how I'm really doing that, I just have like some of these dependencies added into my Spring Boot. It auto configures and then start really feeding the data to these external tool sets, which will really help me build overall observability to my applications. So here, like if you see the first thing, which is the micrometer Prometheus, which will help me export all the metrics that each of the Spring Boot applications to the Prometheus, and then the time series is really maintained and which can really be used for the visualization. And then the actuator is some of the Spring Boot's own internal component, which will provide a mechanism by which these metrics and other informations can really be exported and exposed outside. And then the low-key logback appender, which is we'll just look at it in deep when we look at the logging mechanism, which is basically provides a mechanism for exporting the logs into a centralized log server, which is a low-key in our case. So again, I think that logging, when we really distribute that application, that's one of the challenges, right? Like I have like loggings which be produced in the multiple places. So that is where we really have to build a way which is centralizes the logging. So similarly, Zipkin is basically primarily a trace provider for us. I think we will talk about what we really means tracing in the subsequent slides. So now let's start with logging. So logging, I think, does anybody doesn't know what is logging or don't really do any logging in their applications? No, right? Everybody does the logging. And I think like this is one of those concepts wherein very easy to get it done, but very difficult to get it done right. So that is basically what we really try to target when we try to really have, if we want our observability infrastructure to be accurate and provide a meaningful information, we need to target for that right data logging and the right set of that logging tools that we really incorporate into the Spring Boot application. So if you see here, the Spring Boot has a very strong and a very good foundation to really establish a logging infrastructure on top of it. So in our example, and this is one of the most commonly used logging framework is a logback, which is a default, comes with a Spring Boot. We don't really have to do much to really, if you want to use the logback as our logging framework. Okay, and now some of the best practices again to get the logging done right is we have to identify what is important. Again, I'm just going back to that quote again and again, is like there is nothing like no one size fits all. Each application is different, each business is different, each business domain is different. So you really have to identify what is really important to this application, your application, and do the right level of logging and the right data that is really being logged. And then the format is very important, because the logs are typically, most of the times it's either a text format or it's a JSON format, right? So that is where like so all these tools one way or the other rely upon a pattern parsing and then extracting that right information depending upon the pattern. So the consistent pattern or a consistent format is very important when really doing the logging. And then the next is the levels. So everybody knows like the different log levels, right? Like we have like a debug levels, info levels, error warnings. So that is something is very crucial for any application to, or any log statements to fix the levels at a right level, so that the dashboards can really reflect the right data. If I basically write whatever the log some the incoming request or outgoing request as an error, then the dashboard will be all be red. It will just be flagging errors everywhere. And then the next is basically the correct storage and the rotation. This is something which kind of like offloads. This concept is bit offloaded onto the centralized logging place. But again, so if you don't really do this or handle this correctly, especially in the cloud infrastructure, it can really become like a very huge cost contributor to your cloud infrastructure. So that is where like logging what is important and keeping that data at a right amount of time, identifying, that is basically some of the aspects considered to be best practice and applied or varies depending upon the application to application. So next is basically this is like again a very crucial topic when it comes to the observability. So the metrics, there if you look at the metrics, we really have like if we look at the Google's SRE practice, they call like a 4 golden signals. So saturation, latency, errors and traffic. These are like a 4 golden signals a metrics can generate, which can really depict the application's health. So how do we really like but there is no like a single formula that can really give whether it's a right, it's at a right level or it's at a not at a right level according for these 4 signals. But what it can really do that is there are certain methods which we can really like break these down 4 signals into. So those are like a red methods and a use methods. Red methods, which is basically rate, error and duration. So it is kind of like at an application level wherein you can identify and like look at and observe the metrics, which is basically incoming request and how many of those are really resulting into an errors or what kind of errors it is generating. And then the next is the duration, how much of the duration it is responding. So these 3 aspects is primarily captured in the red metrics, and that can just really like tell about an application status and how application is responding to the incoming user requests and the traffic. And the use method primarily targets around metrics or the data generated from an infrastructure standpoint, which is like an utilization, saturation and errors. So here if you see that errors kind of like an overlaps in both the area. So in the use method, this error is primarily the infrastructure error or from like an underlying hardware error which is really maybe getting generated. And the utilization is about a CPU utilization or be it a memory utilization, at like what level it is being utilized and what we really consider it to be at a dangerous level for each of that application. And again the saturation is kind of like it's varies for a different application. What is we really call it as a saturation, which can really be a signal to really alert us a red flag saying that something is wrong with the application, or it can even also be a signal to really auto scale and then really keep the application ready proactively to take additional workload. So when it comes to the Spring Boot again, the actuator and a Prometheus combination with the Spring Boot can really help us export all these different types of metrics data, and it's up to us really like how we really utilize and how we really like build the dashboards and alerts utilizing these signals which comes out of any Spring Boot application. Yeah. Sorry? Yes, there are like a ways where you can really have a custom metrics, especially like if you take that micrometer or Spring observability framework, it do provide a way wherein you can build your own observe registry, and you can really register how or what is really important you really want to track out of that. So, yeah. Yeah.
So what he's talking about observability, then there is a handler and then yes. So those things if you combine, right, you can generate your own customized
Right. Yeah. It's basically the this micrometer. It's a whole set of APIs. It do provide some of those like a most useful and like a default metrics and a default values out of the box. But on top of that, it provides an API wherein you can hook up your observability handlers into the application and then really watch the whatever the custom data that you really want to monitor. Okay. So now next is a tracing. So Bhuwana will continue with a tracing concept.
Okay. So, why tracing? So tracing, you can say that it's kind of logging. The only thing is that with the more complex microservices or RPC style of calls, tracing is of importance because it helps you correlate between all the logs that are getting fed into your centralized logging, whatever the tracing backends are. So let's take this example, right? So the one example is a shopping cart where you see a customer is trying to purchase something, he's trying to put something in the cart. So basically the request is going to the shopping service, getting the item details, and then it's also going to update the inventory, right, for that item, and then it's going to go respond to the user. You're hearing me well? Or, okay. Yeah, please let me know. Okay, so if you look at this transaction, right, let's say the logs are getting fed from the cart service, the customer client application, and the shopping service and the inventory. So right, imagine you're just going to get thousands of log, not just for one transaction. You're going to let's say in a minute, if you have, let's say, 10 transactions, you're going to get logs from everything into your tracing backends. And imagine what a nightmare it is to identify which trace belong to what request, right? So that's where tracing comes into picture and helps us really identify the logs to traces to the request. So tracing is basically gives you what is happening to the transaction, right, which services it's hitting, right? And what you see here, the trace 1001, that 1001 is the trace ID. It's a unique identifier for the trace, and the spans are nothing but small basic units of work. Let's say a span, a service has one span, right? If it's doing one a request, let's say it's just processing the request and not spawning another child threads or something, right? Simple request, it will one service per one span per service, and you see the cart service has does something, and it's going to take some x units of time. So that's what is represented as the proportionate size of that span, that window that you see there. And then you have each service, like shopping service is going to have a span. Inventory, when it's executing, it's going to send a span. So basically a request, when you trace a request, you're going to see how much time the request is spending on each services, so that it helps you identify the latency. Or not just that, you could even use traces to understand the system better, right? And there's a lot more things you can do with traces. We'll probably cover a few. So that's about traces. Now, one interesting thing about this trace, like if you look at the components of the trace, right? So first, when a request hits the first system, right? So in this case, the client application. So it has to start identifying that request as a unique trace, right? And then as it hits the downline system, it needs to propagate the trace ID to all the systems that it's calling. So if you miss one system, you are going to have a broken trace. So if you look at the components, one is generating a span and handling the life cycle of the span. That's one part. The second part is basically propagating the context. In this case, the context is the trace ID, the generating the spawn IDs, and you could also have more custom metadata that you might want to add to the trace. In this case, it could be like where is this transaction originating, which country or which region it is originating, based on whatever you're interested in observing. So you could create the trace context, propagate the metadata. That is one part. In what format you would propagate? Is there a common standard format that you can add these metadata? So that's one part. The second thing is propagating across the services, meaning let's say you have a service calling another service asynchronously. So how is this service going to propagate the context to the calling service? So that's in one thing, across asynchronous boundaries and also across network calls, right? Let's say it's going to call through HTTP or gRPC protocol, or it could call database, it could call some other messaging system, it could be n number of systems, dependent systems down the line. So capturing the traces across the entire end-to-end transaction is the challenge in defining your traces, and it takes a lot of work, of course. And you have standards coming in. So you have open telemetry, which is going to solve some of the standardization problems, and it's not just limited to this, right? Like if you are on cloud, like the cloud providers have their tracing systems, like Google has this cloud operation, and then you have I think X-ray in Amazon has it. So they have their own flavors of the tracing system. So so when you are in multi-cloud, how are you going to export all your traces if you want to send it to a centralized system and deal with the different formats of tracing? So that's where open tracing and open telemetry comes into picture. And let's just look at some of the things that's there in Spring. So what Springboot tries to solve is, they have one micrometer tracing API, which is kind of you can use it for any of your tracers. So you have you have a bridge kind of a thing. So if you want to use Brave or Open Telemetry, you could use any of it. So it kind of decouples the implementation with the API, and also helps you prevent vendor lock-in in this case. And the default tracing format is the W3C format, and also supports the B3 format. And then you export these logs to whatever backend that you want to. You could send it to probably Tempo. You could probably send it to Cassandra. If you want to build a more robust data mining system, you could do all of that on top of your tracing framework. So all of that is possible. And so we'll like to move on, because when Prashant is going to take the demo, I think we will cover more on what you see in tracing, so that I don't want to give too much of theory, so you can't connect the demo with the theory and what you see in traces. So you'll be able to appreciate it more. So some of the best practices that we want to share is target for the right data. Like Prashant said, you know your application better, so you know what data would make sense. So start small, start with the right data. Build tools where you can visualize the data, and also as you keep observing, it's kind of it's an evolving process. You don't build a tracing system and leave it there. As you implement new features and you see more and more things that you have missed, you are going to keep refining your tracing systems and what you are collecting, right? So base your decisions on what you are observing, and then keep the signals 3 to 5. We recommend at most 7 to 10, and then more on that, right? It's not just about the numbers, right? Numbers is not going to solve anything, or any amount of tooling is not going to solve anything. Of course, it will help us get the data, get the information first, but then it's not going to solve. You have to understand your failure domain well, right? So that you know where you have to put your tracing points, right, and what data you want to collect or propagate throughout the services, and you will have to understand the system interactions. So let's say at the end of the tracing you see a lot of spaghetti kind of service calls, then it means that you have not broken down or got your microservices architecture right. Maybe you have to re-architect some of it and put some of the services under a single domain, right, or all of that, and maybe the boundaries are not well defined, and you might need to work on some of those things. And good intuition is built only as you solve more and more problems, and that's something that you will start developing as you solve more. And with that, I'll hand over for the demo.
Okay. Yeah, before getting into the demo, I think I just want to switch back to this slide for a minute, because this is what really connects to the demo. So this is exactly what I'm really going to do the demo. What I really have is like these 3 microservices, which is really like streaming the data to the observability infrastructure: Prometheus, Loki, Zipkin, and Grafana dashboard on top of these 3 aggregators is what I really have set up. So here, because I did not really build like too much into the custom dashboards or a custom metrics here, because I just wanted to showcase like how Spring Boot is easy to really get started with, and then really expose some of the key metrics automatically without really writing a single line of code explicitly for it. Right. So here I have like my microservices code. I think I'll start with how we can really set up the dependencies for it, right? So I think, as you have seen in the slides, I do have like an actuator as like one of my Spring Boot a starter library thrown into my application dependency. And then I have like a tracing bridge Brave, which is basically provides a bridge between Micrometer and Zipkin for the tracing purpose. And then, of course, yes, I need the trace to be streamed into the Zipkin, so I have the Zipkin dependency. And then I have the Prometheus, wherein I need my actuator to expose a data to the Prometheus, where the Prometheus can understand it in a format where Prometheus can understand. So I have the same set of dependencies in all my microservice, and with these dependencies I don't have like even a single line of code written in the application which can really to get me the metrics data or get the observability stack up and running. Yeah, and of course the Loki logback appender, which is primarily to stream my log data into the Loki. It's a Spring Boot 3. So I think, yeah, this observability framework with Spring Boot 3 is basically so far the best available integration that what we really have till now. Again, I think there were like some of the even the older version, there was like a bits and pieces, but the 3 kind of like tries to bring everything together and provides it as like a good package to get started. So with this, I think I'll just quickly go through like how I did set it up. So it's basically like I have like my own like a single node Kubernetes cluster running all the applications. So if you see here, I have like 3 microservices running, and then even I do have all my even the observability stack as part of the same minikube. So it's basically all the single node and like with a very minimum resources, and in memory time series data storage is what it really using for the demo. So now I'll just go back and send some requests to my application. So this application is primarily kind of like a shopping cart and a purchase microservices. So I'll start with sending some requests to the shop, and I'll have the shopping response, and then I'll just add a couple of items to the cart. So I added a cart, and also I'll just basically generate some errors, which is I try to add some invalid item to the cart, which will give me a 500 error. And then I'll just go to the cart and try to really fetch the cart. Like I have like 2 items added to the cart, and then I'll just go ahead and try to purchase this. okay, I have my purchase, and then I just try to see what I really, oops, something going wrong here. That's fine, actually. Okay, so now I'll go back to my dashboards to see that what it could have been really happened, right? So I'm using Grafana as my dashboard, and I really used some of the default dashboards that what Grafana has really used in their demos, and this one just connecting to that backend microservices what I really have. So here, if I look at this observability, so this is primarily giving me the red metrics what we really talked about, right? So if you basically talking about a total number of requests, which endpoint really received, what are the different requests, and then how many of those are really failed, and what is my failure rate, and then also this histogram, which is really telling me that, okay, what are the requests which is really taking more time versus what is really taking the less. And this histogram is typically a relative one. It doesn't really have like an absolute value defined as of now. It's basically like whatever among the requests, it's just I tries to evaluate and come up with an average mean time to define it, whether it's a green or a red. And then it's basically there are like some of the others, the percentile values, and then if you see here, this is an interesting dashboard item here, which is primarily showing a failed request, that errors which is really generated from my transaction, and also some of these the log rates. This is primarily puts a green and a red logs versus like an information and error logs which that my application might have generated. And all these are like kind of like a time series, and it keeps updating with the time with like a little bit few seconds of a delay. It typically starts to appear in the dashboard, and it keeps refreshing itself. So now let me just try to pick one of these trays and then try to go to the Zipkin and see that if I can really pull the pull that trace to see what it's really happened. Again, I think sometimes it takes some time, and it's just you just have to really wait it to refresh. And if you see here, like the tracing, I think what we really shown in like a very simplified form in the slide, that is exactly something you can see that. So from my request has for this particular trace ID started all the way from gateway, and then it really gone into the cart, and then it from the cart it tries to go to the shopping to really get the details about the item that I'm trying to add the cart, and then for some reason something went really wrong and it failed. So again, I think if you see here, it has the traces going all the way till the shopping to get the details, and then the failures on the reverse path, like what are all the path it really failure has really cascaded back. So the shopping is where like this the get catalog is where it really failed, because I tried to add an item into the catalog with a wrong ID which was not there in the catalog at all, right? So this is exactly what this is the very simplistic representation, but as the microservices infrastructure starts growing like beyond like hundreds of services, then this plays a very crucial role to really track where exactly things are going wrong and what exactly may be the reason for the failures. And along with that, it's not just about failures or how the request is propagating. It's also, if you see here closely, it pointing out the time each stage is really taking. So it can also help us identify and fix some of the performance bottlenecks that applications may really be going through. So with this, I'll just want to show one more dashboard, which is primarily talking about use metrics, right? So this is, if you see this one, it's talking about it's providing all bunch of information about the JVM statistics, right? So if you see here, this is again like not really something custom built. It is something that I picked up out right from Grafana's their GitHub examples. So, but it itself is like showcasing so much of a data information that I can really customize for my use case, and then I can just utilize it for alerting purposes. So here I can just pick at my different microservice and then check how each of these microservices are doing, and like what is there any bottleneck in any of those microservices. It's a kind of like gives complete information about the JVM. And another thing is like, so the when we use the Grafana, it is even provides some of those integration, right? Like, so if I see here, I have like a 3 services, all 3 kind of like a link to the Grafana, which is really streaming the services to Grafana. So even I can even use it to really look at any specific items, right? So if I see here, like, yeah, add to cart count, how much of this add to cart count is really this one, right? Like, it's a all the labels or all the metrics that whatever that Spring Boot is exposing by default is available for me to really like watch out, and then really like it opens up an endless opportunity, right? Like I can just look at the right data and then create a visualization or a dashboard according to my need. Similarly, this Loki can even help us get the application logs. So here, if you see here, my application logs are being streamed, and I do really like, if I really want to dig more into the logs to really troubleshoot, I identify my trace, I identify like which service that problem is really happening, then this can just be a tool wherein I can just go ahead and pick the traces or pick the stack trace and identify like what is really going wrong with the particular service. So with that, kind of like end of the demo, probably we can I don't know whether we have time for questions or not.
Oh, any questions you can reach out to them.
Okay.
This blessing ID, is it recommended to go to the end user or it's only for
No, it's for the internal. It's not really recommended to really expose it to the end user. It's also primarily for your like an internal usage. It's not really
for example,
something.
if I'm going to check out some product, balance got deducted from my account,
Mhm.
and so it said order cancelled.
Mhm.
As a customer, I'll get panic like what happened.
Yeah.
So for me to track something,
Correct. So that is where like you need to have like your application has to really provide certain meaningful IDs or some error codes to the user, right? That is something which will really like trace it back to the. So don't really confuse between a user session and a trace ID. Trace ID is a request scoped ID. Each request. So if one user is making 10 requests, there are 10 traces for that. But the user session, this is like a one common user session for that all his 10 requests within, if he's really doing it within like one session, right? So this traces is primarily is more to really like track your microservices workflow, not really the user standpoint.
So you are not